Hello everyone, my name is Bill Dehorty. I'm a development manager at Bentley Systems involved with iTwin connector development. In a moment, I'll turn the presentation over to Olav Sylthe, who will tell you about FutureOn and FieldTwin and some of the exciting things that FutureOn and Bentley are doing together in the energy sector. But before I do that, I want to plant a thought in your mind. This is a slide I've borrowed from Olav's presentation that you're about to see. Don't try to absorb it all here. Olav does a great job of building up to it. For my purposes here, let me simplify it to this. The thought I want to plant in your mind is this. As you watch and listen to Olav's presentation, keep in mind that a lot of the magic that occurs between FutureOn's FieldTwin and Bentley's iTwin happens by virtue of that FutureOn connector thing in the middle. After Olav's presentation, we'll drill down more on what that means and how that is a basic design pattern supported by iTwins. But for now, let's turn it over to Olav.
Hello everyone, my name is Olav Sylthe. I'm the CTO of FutureOn, and I'm here today to talk about FieldTwin, our cloud-based digital energy platform. In this day and age, digitalization is very important. And on the right-hand side, you see a lot of the buzzwords that's going around the industry right now. But FutureOn really cares about the data. And why is that important? Well, Forrester research tells us between 60 and 73% of the data that you as an enterprise have access to is not necessarily used in the decision-making process. And we want to change that. Because when we work with our client in the conventional field planning process, we saw that a lot of meetings are held. A lot of data goes in the form of email attachments, you print them out, you make revisions, you edit them, you meet again. And the time until the approval phase is long. So what if there was a better way to do that? What if you didn't have to spend 2/3 of your time just gathering data and making sure you have the right data to make decisions? What if you actually could have a collaborative digital way of doing this to do a much more efficient field planning for any sort of energy project, and the domain experts and the project owners can work together on the same data set and fast track this to the approval phase. And with data always updated and always accessible anywhere at any time, this becomes much more efficient. And if the same data set can also be shared between the different partners in the ecosystems, operators, engineering companies, marine installers, platform contractors, what if they all can collaborate on the same data set to make it much more efficient? So I thought I'd show you a little video on how this works. So what is FieldTwin? Well, FieldTwin is both software as a service and platform as a service. We're completely cloud agnostic and completely container based. We run in your browser, so there's no installation to be done, and we offer our service on the SaaS side as both a multi and single tenant service. It's available around the clock, around the year. It's very secure, scalable, and reliable. And everything we do is based on open standards. And everything is powered by our REST API. So this is a data-driven design platform, because as I mentioned, data is key for FutureOn. And at the heart is the digital FieldTwin model. This is a generic network topology domain model of your field. So typically this is comprised of descriptions and data storage for pipelines, assets, 3D surfaces, well data, cost data, but also our extensible metadata model that allows you to grow and enrich this model over the life of field, which can be 20 to 50 years maybe. So you typically start out by ingesting data. Seabed data, bathymetry or survey data gets ingested and converted into a digital elevation model. You then design your layout using our generic asset library, or if you have your own asset library, you can use that as well. You place out your topside assets and vessels and connect them. You add reservoir scans, you add the well paths, and you can also integrate directly with sensor IoT data if you like. And once you've done all this data ingestion, you actually have the design data shown in 2D and in 3D. This is data we got from Equinor, from the Tyrihans field, and from we received the data to it was live and accessible around the world to permitted users, it was 40 minutes. And now everyone could see what was going on from all the different expert domains and collaborate on the same model. And this goes for any sort of energy project, whether it be offshore wind, or it could be solar, or it could be onshore projects. So metadata, this is another key element. This is where you make the engineering descriptions for what you need in your project. So typically that would be describing the pipelines, it could be the materials, it could be the fluids, it could be cost related. So as you do your design, it updates the costs and also have all the attributes needed to later on run calculations, simulations, analytics as a service, connecting with the platform through the API. And having a single source of truth makes for decision making so much better. And as you then follow the different phases of the life cycle of the field, which is maybe 30 to 50 years, this data model, this digital field twin grows over time and gets enriched and can follow you all the way to shutdown of the project, the plug-in abandonment phase. One of the key strengths of Field Activity Planner, which runs on FieldTwin, is the ability to create numerous layouts, different concepts if you like. And then you can contrast and compare the cost of these concepts, the CAPEX, the OPEX, or installation time, all to help you narrow that down to maybe one or two concepts that you want to then run engineering calculations, going from pre-engineering to engineered. And that means concept design, getting you the production network model, and running engineering simulation and calculations, and doing the final concept select. Because at heart, this is a generic network topology that you can access programmatically, and you can integrate all sorts of engineering packages with it. Because we have an API-first architecture, so everything is described in the FieldTwin model and can then be connected to other expert systems. And the API can deal with map sources, sensor data, engineering integration, simulations, backend system, calculations, costing. But really what's important is also the connectivity with digital twins. So, as I mentioned, everything is accessible through the REST API. You can add, remove, edit metadata. You can actually create or retrieve entire field layouts programmatically using the API. You can get the pipeline and engineering data for the pipeline and run engineering calculations. And most importantly, everything is seamlessly synchronizable with iTwin. So within FieldTwin, you can also embed any sort of tab, which is an iframe, so you can have your KPI dashboard from Power BI. You can also take FieldTwin layouts and embed directly as an iframe in your own applications, or just build on top of our API and create your own solutions with their own UI. And when it comes to the FieldTwin and iTwin synchronization, this is very powerful because we can ingest a lot of the data used in the energy field layout to get to the design and concept select. In the concept design, you can hook up all sorts of calculators, simulators, engineering services, and then the synchronization brings all this data into the digital twin and enable iTwin workflows. So that means you have enterprise workflows for review, validation, insights, and any sort of dashboard that you might need. So this enables collaboration across the board, knowledge sharing, better quality of the communication, speeds up the process, has better quality on coordination, and has a digital working environment for everyone. And that means substantial cost savings and reduced time to market, and also better risk management. And again, improved engineering performance also means that you have increased field profitability. And together, FieldTwin and iTwin, using the iModel bridge, allows this synchronized digital energy domain models for rapid visual iTwin enterprise workflows. Thank you so much for listening.
Hello again, everyone. Bill Dehorty back with you. First, let me say thank you to Olav for that very nice and informative presentation. What you see on the screen now is the online page that holds one of the presentations given at Bentley's virtual Year in Infrastructure conference last month. This particular session, as you can see, was entitled Making the Business Case for Digital Twins, hosted by Adam Klatskin, shown here in the upper right, along with Richard Cooper. If you saw that session, you might recall that amongst the many guest speakers that contributed to it was Josh Etkin from Shell. We've extracted a 1-minute snippet of Josh's talk to present here for two reasons. First, it makes a great exclamation point to Olav's presentation, letting you hear about the benefits of using FieldTwin with iTwin from an owner-operator's perspective. And secondly, Josh's video showing FutureOn's Field app to create design concepts and Bentley's design insights to perform cost analysis against them is an ideal lead-in to the next two segments of our presentation today, where two developers who worked on the FutureOn connector will shed more light on how that connector works. Here's Josh.
So how much time? We're looking to trigger a roughly 30% reduction in the amount of time it takes us to come up with concepts and select them and move into the engineering phase. A concept engineer can now take a concept and kind of rough it up in 3 dimensions within this platform. And they can do 2, 3, 6, 10 different concepts within a couple of minutes, as quickly as they could drawing it on a whiteboard or mocking it up on a PowerPoint slide. The magical aspect of this is that now all of the cost and schedule data is connected to those standard engineering packages in 3 dimensions. So with the click of a button, we're now able to actually identify and calculate and visualize how all of those different solutions stack up against one another. So you'll have professional looking waterfall charts that show the cost and schedule comparisons. And that makes the concept selection process quite simple. What used to take us months to do is now can be done live.
Thanks to Josh Etkind and Shell for sharing that demonstration with us. As you saw there, multiple concepts produced in FutureOn's Field app browser client became accessible in Bentley's iTwin. Once there, Josh showed the cost evaluation being done using the concept compare feature of Bentley's Design Insights. But one point that the video glossed over was at what point do the Field app concepts actually flow from the FieldTwin over to the iTwin? How is that accomplished? In the next two short segments, Adam McCarthy and Akshay Madhukar will explain when the concept data flows to the iTwin, and once there, cover a few additional things that can be done with it.
My name is Adam McCarthy, and I'm one of the developers for the FutureOn connector here at Bentley, and this presentation will just be a quick demonstration of the solution we implemented for going from a FutureOn FieldTwin to creating a Bentley iTwin using the FutureOn connector. This page here is a sample project that we've created inside the FutureOn Field app that is modeled and ready to be synchronized into an iTwin. In order to do that, we'll use one of the tabs that Olav mentioned in his presentation earlier, which we've configured to use a small UI that is hosted in Bentley's Instant On service. I've already configured everything needed to send it off, but all you would need to send it off is just a couple of IDs for the Bentley project and model for the twin you want to synchronize to. After you set those values, all you would need to do is click the Synchronize button, which will gather all the data the connector needs from the values configured, and send it off to an API in Bentley's conversion service that will queue a job to launch the FutureOn connector and convert the data. After you've done this, you'll be able to monitor the progress of the job here, as well as use the links provided to get to a couple of locations in Bentley where you could use the twin that we just created. For example, to use the cost and scheduling comparison feature that Josh showed off in his video a few minutes ago.
I'm Akshay Madhukar, and I'm a developer working on the FutureOn connector. I'm going to be picking up where Adam left off. So after we sync up our project from FutureOn into the iTwin, we get the following result. So the first thing I want to do is to compare the graphics of the FieldTwin on the left to the iTwin on the right. And as you can see, the iTwin has the capability to match the graphics coming in from the FieldTwin. So here we see a close-up shot of a manifold, and even at this fine level, we see that the iTwin on the right matches with the FieldTwin on the left. So now that we've seen the graphical capabilities of this connector, I want to talk about the benefits of iTwin and the power that it brings. The first example I want to show is concept comparison. Within this iTwin, I can quickly and visually see the difference between concepts. In this display, only the base layout is shown. The base layout here is a brown field, meaning that it's an already existing field on the seabed. Now I'm going to turn on concept 1, and as you can see, you can easily spot where this concept has been added. And if I switch over to concept 2, you can quickly contrast the two of them. Another benefit of connectors is that you gain a greater flexibility to analyze and query your data. For example, once we have our data in an iTwin, we can run a Power BI connector and gain access to the suite of tools that Power BI brings. Here, you can see the iTwin visualizer for Power BI showing the base layout along with the two concepts that we saw earlier. And now we can use Power BI to analyze and understand this data. So this data is completely interactive. And if I select, let's say, concept 1, I can see that this change reflects in the iTwin visualizer for Power BI. And in fact, I can go further and select individual plans or individual units such as this. I can go ahead and interact with this data as I please. So the exciting part of having this data in a Power BI report is that I can bring in other data sources and have it show up alongside with the data coming in from the iTwin.
Let's summarize where we've been so far. First, Olav Sylthe of FutureOn gave us background information on FieldTwin and FieldApp and mentioned how the FutureOn connector is used to integrate them with Bentley's iTwin environment. Next, Josh Etkind of Shell helped to ground that integration in terms of stating real benefits that Shell, as an owner-operator, is reaping from this technology integration. Then Adam McCarthy of Bentley dug in just a little bit on how the integration is carried out at a high level as a synchronization activity implemented in an iframe of FutureOn's FieldApp client. And finally, Akshay Madhukar pointed out other ways in which the synchronized data may be consumed, from graphical viewing and designer view to report data transmitted through a Power BI connector. That brings us to the live Q&A session. As a last note, for those of you who think you might want to write your own iTwin connector, either to something as sophisticated as the FutureOn FieldTwin, or even something as simple as an Excel spreadsheet, we want to leave you with some information to get started doing that. But first, let's end the pre-recorded segment of this presentation and take your questions related to the material shown so far to this point. And then, as part of that Q&A session, we'll provide you with links to information for how to write an iTwin connector. Thank you for attending our presentation.